All right, so this is one of the problems we had in class to work on. It goes a 500 kilogram piano is being lowered into position by a crane, while two people steady it with ropes pulling to the sides. Bob's rope pulls to the left 15 degrees below the horizontal with 500 newtons of tension. Ellen's rope pulls toward the right 25 degrees below horizontal. Part A asks, what tension must Ellen maintain in her rope to keep the piano descending vertically at constant speed? Part B then says, what is the tension in the vertical main cable supporting the piano? So you can see I've already drawn our free body diagram. We've got the weight going down. We've got Bob's force pulling in one direction and Elaine's force pulling in the other direction, both pulling in the downward direction. And then we have the force of the main cable supporting everything up there. First thing I want to do is I want to draw in these components for these two diagonal forces. So I've got the force of Elaine in the x direction, and I have the force of Elaine in the y direction. I then have the force of Bob in the x direction and the force of Bob in the y direction. So there we go. There's a good free body diagram that we can deal with. Now part A again asks, how much force does Elaine need to apply? Now Elaine is is pulling at an angle, but it looks like my best bet, my easiest bet, is to start in the x direction here, because it's a simpler direction. We've only got two forces acting here, and if that doesn't work out, I can always try the y direction. So I'm going to start with the sum of the forces in the x is equal to ma sub x. Now it's moving at constant velocity, so we're going to assume that a sub x is 0. So we get then the force of Elaine in the x direction minus the force of Bob in the x direction is equal to 0. So if we plug in what we know, we've got the force of Elaine times the cosine of 25 is equal to the force of Bob, which is 500, times the cosine of 15. Right, and if we do the math, find out what these products are, divide by the cosine of 25, we find that Elaine needs to apply a force of 533 newtons. The next thing they would like us to do is find out what is the force in the main cable. So, force in the main cable, it's in the y direction, so I'm going to go there and I'm going to do sum of the forces in the y is equal to ma sub y. Again, we're moving in constant velocity, so the acceleration is equal to 0. Now we've got quite a few forces here. We've got 4 forces acting, so we need to include them all in here. So I've got the force of the main cable, I've got the weight, I've got the y component of Bob, and I have the y component of Elaine, and they're all equal to 0. So the sum of them, they all have to cancel out. So I've got the main cable, it's going up, so it's positive, but minus, minus, and minus these 3 forces because they're all pointing downwards. So just from here, plug in what we know. I've got the force of the main cable. The weight is going to be 500 times 10, right? Weight equals mass times gravity. I've got the force of Bob, which is going to be 500 times the sine of 15, and then minus the force of Elaine, which we just found, of 533 times the sine of 25. So from there, it's all pretty simple algebra, and we should find that the force of the main cable has to be equal to 5,355 newtons. So there you go, pretty standard Newton's second law problem.